Greetings! My name is Dr. Fuller. I would like to introduce you to the mathematical world around you. Today we are going to go a step further with fractions and tackle multiplication. This skill has countless uses. Say you're in construction or landscaping, you might need to calculate half a quarter acre of land, which requires multiplying fractions. Or maybe you're working in finance figuring out investment returns, where multiplying fractions is key. Besides, since a fraction can be thought of as a division problem, you may be calculating something where you must combine multiplication and division. To make this process easy to follow, we will use a tool called the area model. This visual method will help you see how fractions combine. We'll do some hands-on guided practice using pictures to help you understand the math behind it. By the end, you'll see how fractions are a powerful tool you can use daily, not just a math topic. Fractions are a way to represent part of a whole. In a fraction, the numerator tells you how many pieces you have or are considering, while the denominator identifies the number of equal-sized pieces that make up one whole. Now, let's think about multiplying fractions to answer questions like, what if I only need part of a portion? And how much is part of something divided? For example, if you need half of a third of a cup of flour for a recipe, you'd multiply 1/2 by 1/3. The result will tell you the fraction of flour you need. Another example might be if you wanted to know how much is 3/4 of a cake already split into 3 pieces with 1 piece missing. You could multiply 3/4 by 2/3 to find out the amount of cake. In just a minute, we'll use the area model to visualize this process, making calculations easier to understand. The area model will help us move from seeing fractions as just numbers to understanding them as parts of a whole that combine in clear, visual ways. Let's get started and unlock the real-world power of fractions. The area model is a way to visualize multiplication. For example, we can model the multiplication problem 5 times 4 as follows. Begin by drawing a rectangle with one side 5 units long and the other side 4 units long. Next, we find the area. Since each square inside is 1 unit by 1 unit, they each have an area of 1 unit squared. Count the number of squares in the array. The area of the rectangle is the solution to the multiplication problem. The area of the rectangle is 20 units squared, so the answer to the multiplication problem, 5 times 4, is 20. By dividing a rectangle into unit squares, the model allows you to see how the factors in a multiplication problem relate to the total number of unit squares, which is the product. The model shows how multiplication is the same as repeated addition. Let's practice an example with whole numbers before moving on to fractions. Max is an artist and is designing a quilt. 3 sections are rectangles made of 1-inch square blocks. If the blue section is 5 inches by 3 inches, the orange section is 11 inches by 4 inches, and the gray section is 7 inches by 15 inches, how many blocks are needed of each color? I begin by drawing each section as a rectangle using the dimensions as the side lengths. The blue section is 5 inches by 3 inches, giving us a grid of 3 groups of 5 for a total of 15 blue squares. The orange section is 11 inches by 4 inches, so there are 11 blocks across in 4 rows. This is a total of 44 orange squares. Finally, the gray section is 7 inches by 15 inches, having 15 rows with 7 blocks in each. This gives 105 total gray squares. Now, let's look at how this works with fractions. Imagine you have half a box of cereal. You eat 1/4 of that half for breakfast. How much of the whole box did you eat? For this problem, since both values are less than 1 whole, we can use a single unit square to model the situation. One square represents one whole box of cereal. First, I represent 1/2. I divide the square into 2 equal parts and shade in 1/2. Now, we represent the other fraction from the other direction. This fraction is 1/4, so divide the square into 4 equal parts. Then shade in 1 of the fourths. Just like with whole numbers, we count the answer shown in the model. The answer is the number of pieces shaded in both times. It's part of a part. This is a fraction out of the total number of pieces the unit square is broken into. In this case, one piece is shaded both times and the whole square is broken into 8 parts. So the answer is 1/8. This means you ate 1/8 of the box of cereal. Let's use the area model to practice a few problems. 2/3 of Max's quilt is cotton. 3/4 of the cotton material is hand-dyed. How much of the quilt is made of hand-dyed cotton? Divide your model into 3 portions in one direction and shade in 2 of them. This represents the 2/3 of the quilt that is cotton. Next, divide the model into 4 portions in the other direction, shading in 3 of them. This part represents the hand-dyed part. Counting the portions shaded both times gives 6. There are a total of 12 portions in the model. 6 out of 12, or 6/12 of Max's quilt, is hand-dyed cotton. The model also works with values greater than 1, though it is critical to keep track of how many pieces make up one whole, as the product may be larger than 1. Max put binding around the outside edge of the quilt, which is made of pieces 2/3 of an inch wide. One section of the quilt needs 4 1/2 inches of material for binding. What is the total area of binding in this section? One of the numbers is greater than 1. To show this, I use a unit square for each whole number and another piece for the fraction. In this example, 4 1/2 is represented with 4 squares plus half of the 5th square. Finally, I break each of the squares representing whole values into halves. This way, all of the pieces represent the same size. The other direction represents the other factor, 2/3. In this case, we will break the side into 3 pieces and shade in 2. Again, the solution comes from counting the blocks shaded in both times. In this example, 18 pieces are shaded twice. As before, this is the numerator of our solution. However, our denominator represents the number of pieces that make up one whole. It takes 6 pieces to make one whole. Our solution is 18/6. I will rewrite this fraction so it is easier to understand. We can group the 18 pieces into 3 sets of 6 with nothing left over. Max needs 3 square inches of material for binding in this section. If any pieces had been left over, our answer would include a fraction. By the way, if your squares are not perfect, it's okay. Even if your squares look like this, as long as you know what the pieces represent, you'll be fine. Max plans to cover 1/2 of a section of the quilt with paint. The section has an area of 2 1/2 feet squared. What is the area of the painted section? Begin with the section that is greater than 1, drawing 3 rectangles to represent the area 2 1/2 feet squared. Then split each in half to accommodate the 1/2. Shade in 5 of the 6 areas. Then portion the other direction into 2 pieces. Shade in 1 to represent the 1/2. Counting the pieces that are shaded twice, we see 5 sections shaded in. It takes 4 sections to make one whole this time. The 5 sections form one whole of 4 pieces with 1 remaining. Therefore, the painted area is 1 1/4 feet squared. There are many reasons we often find part of a part, so multiplying fractions is a skill we frequently rely on. While drawing models of fractions is not always efficient, sketching representations of problems involving multiplication of fractions can help you understand what's happening. In my mathematical world, I have one little problem. Max said that multiplying fractions pops up in art more often than one might realize. Help me understand these situations. Max is creating a mosaic. 2/5 of the total piece is completed, and of that completed portion, 1/2 is made up of green tiles. What fraction of the completed mosaic is green? Max is painting a mural. The mural is divided into 4 sections, and Max has finished 3/4 of one section. If each section is the same size, what fraction of the entire mural is completed? Max sculpted a clay dish and used 2/3 of a 5-pound bag of clay. How many pounds of clay did Max use? Max is designing a stained glass window where 1/2 of the area will be shades of red glass. Max has only finished 2/3 of the red section. What fraction of the entire window is finished? Max is drawing a comic book. Each of the 10 pages has 6 panels, and Max has finished drawing 2/3 of the panels. What fraction of the total panels has Max drawn? Max is weaving a tapestry. The final design is 14 1/2 inches long. 3/5 of the length is a floral design. How many inches long is the floral design? Max built a sculpture and used 2 1/2 meters of wire. 2/3 of that were copper wire. How many meters of copper wire did Max use? Max is designing a poster. 2/5 of the poster is covered in images, and 1/4 of those images are photographs. What fraction of the entire poster is covered in photographs? Max is making jewelry. Each necklace requires 3/4 of a meter of string. Max wants to make 4 1/2 necklaces. How many meters of string does Max need? Max illustrates a children's book. 1/2 of the illustrations are finished, and 1/3 of those finished illustrations are for the first chapter. What fraction of the total illustrations are for the first chapter? Max calculates the time spent creating a new mural. If the project took 10 1/4 hours and 1/8 of the time was spent planning, how much time was spent planning? Take a look and you will see a mathematical world around you filled with fractions. Now that you've seen how multiplying fractions works and how the area model helps us visualize it, you're ready to use this skill in the real world. Whether you're cooking, creating art, or even planning your next big video game strategy, fractions are everywhere. Understanding how to work with parts of a whole will help you make smarter decisions and solve problems in ways that matter to you. So, the next time you're splitting a pizza or figuring out how much time you have to finish a project, remember, fractions are your secret tool. With this new knowledge, you've got the power to break down and conquer just about anything that involves parts of a whole.